Welcome to part 2 of naming alkenes. We're going to go into some more in-depth examples. So what I've drawn here is a ring with 7 carbons. You don't usually see this because these rings aren't stable. However, in this case we have a chloro substituent and we have 3 double bonds. How are we going to name this? So to number it, we want to start at a double bond and always make sure that we're prioritizing the double bonds and not the chloro. As you can see, we have 7 carbons in total, which would usually be equivalent to heptene if we had 1 double bond. However, we have 3 double bonds, which would be heptadiene. And we have a ring structure, or actually heptatriene, because tri means 3 double bonds. Since we have a ring structure, this is going to be cycloheptatriene. And in this case, you do need to specify the positions of the double bonds on the ring because you actually have more than 1 double bond on the ring. So this double bond is across 1 and 2, but we're going to go with 1. This one's across 3 and 4. We're going to go with 3 since it's lower. This one is across 5 and 6. We're going to go with 5. So it'd be 1, 3, 5, cycloheptatriene. We also have a chlorine on carbon number 7. So this would be 7 chloro. How do we count the longest chain in this example? We don't want to start going like this because we want to include the double bond in the longest chain. So we're going to start at the carbon where the double bond starts. And we also don't want to go like this. We want to go like this because even though this looks like an ethyl substituent, it's actually part of the longer chain. It's just not drawn straight out, it's drawn slanted. But that doesn't mean that it's a substituent, that just means that it's a longer substituent looking part of the main chain. You can see that we have 8 carbons, which is decene. And our double bond is between carbons 1 and 2, so we're going to go with 1 decene. We have a methyl on position 2, so that's 2 methyl. We also have a methyl on position 6, which is 6 methyl. So since we have 2 of the same substituent, we're going to go 2, 6, and then we're going to put a di behind the methyl, and then the parent chain name, which is 1 decene. Let's talk about these 2 examples. How would you name the structure on the left? As you can see, we have 1, 2, 3, 4 carbons, and the bond is between carbons 2 and 3. So it'd be 2-butene, right? The example on the right, we also have 4 carbons, and the double bond is in between 2 and 3. So it'd also be 2-butene. But notice that the structures look different. The structure on the left has the methyl groups going in opposite directions. One is going up, the other one's going down. The one on the right, both of them are going down. This is what you call a cis-trans isomerism. The structure on the right is going to be a cis isomer. The one on the left is going to be a trans isomer. So in order to name these, you'd put cis 2-butene, and with this one you put trans 2-butene. Di is a diiodine, by the way. Iodine atom. In this situation, if you count the carbons up, you have 4 carbons. And the reason we counted this direction as opposed to this direction is to give the iodine the lowest number possible. And we want to prioritize the iodine in this case because whether you count left to right or right to left, it's not going to make a difference for the double bond. So whenever it doesn't make a difference for the double bond, you always want to prioritize any other substituents, in this case the iodine. 4 carbons is butene, and it's 2-butene specifically. We also have an iodo or iodine on carbon number 2, so the name of that substitution would be 2-iodo. However, is this a cis or a trans isomer? As you can see, the methyl groups, which are the same groups as one another, they're actually going in opposite directions. And when you have things going in opposite directions that are... Well, let's rephrase this. When you have 2 of the same groups, in this case methyls, going in opposite directions across the double bond, that's called a trans. If those methyls had been hydrogens, it would still be trans. If those methyls had been bromines, this would still be trans. It could be any group, but it has to be the same 2 groups going in opposite directions. It'd be trans. And if two of the same groups across the double bond are going in the same direction, that'd be a cis. So I hope that was helpful. Thank you for watching.